Good day, everyone. We are the Group 2. I'm Miss Mullion together with Miss Baranda, Mr. Caraig, Miss Chico, Miss Dalangin, Mr. Fruelda, and Miss Lacson will discuss the Chapter 11 Enterprise Resource Planning System. For the learning objectives, after studying this chapter, you should understand the general functionality and key elements of ERP system, understand the various aspects of ERP configurations including servers, databases, and the use of bolt-on software, understand the purpose of data warehousing as a strategic tool, and recognize the issues related to the design, maintenance, and operation of a data warehouse. Recognize the risk associated with ERP implementation. Be aware of the key considerations related to ERP implementation. And lastly is to understand the internal control and auditing implications associated with ERP. Next slide, please. Let's start in defining what is an enterprise resource planning system. ERP are multiple module software packages that evolve primarily from traditional and manufacturing resource planning system. The objective of ERP is to integrate key processes of the organization such as order entry, manufacturing, procurement and accounts payable, payroll, and human resources. By doing so, a single computer system can serve the unique needs of each functional area. Unlike in the traditional model, each functional area or department has its own computer system optimized the way it does its daily business. For an easy and smooth operation, ERP system combines all of these into a single integrated system that accesses a single database to facilitate the sharing of information and to improve communications across the organization. Next slide, please. To illustrate, consider the traditional model for a manufacturing firm illustrated in Figure 11.1. So this company employs a closed database architecture, which is similar in concept to the basic flat file model. Under this approach, a database management system is used to provide minimal technological advantage over the flat file system. When a customer places an order, the order begins a paper-based journey around the company where it will be input into the system of several different departments. This redundant task cause delays and lost order, as well as promote data entry errors. During transit through the various system, the status of the order may be unknown at any point in time. For example, responding to a customer query, the marketing department may be unable to look into the reduction database to determine whether an order has been manufactured. Instead, the frustrated customer is told to call the manufacturing. Similarly, the procurement of raw materials from suppliers is not linked to customer orders until they reach the manufacturing stage. So this results in delays because manufacturing awaits the arrival of needed materials or in excessive investments in inventories to avoid stockouts. The lack of effective communication between systems in the traditional model is often the consequence of the fragmented system design process. Each system tends to be designed as a solution to a specific operation problem rather than as a part of an overall strategy. Furthermore, because systems designed in-house emerge independently and over time, they are often constructed on different and incompatible technology platforms. That's why ERP system was created to support a smooth and seamless flow of information across the organization by providing a standardized environment for a firm's business processes and a common operational database that supports communication. Next slide, please. ERP functionality falls into two general groups of applications, core applications and business analysis application. First is we have the core application. Core applications are those applications that operationally support the day-to-day activities of the business. If this application fail, so does the business. Typical core applications include but are not limited to sales and distribution, business planning, production planning, shop floor control, and logistics. Core applications are also called online transaction processing or OLTP applications. Figure 11.2 illustrates these functions applied to a manufacturing firm. Next slide, please. To discuss each core function, first is we have sales and distribution function. It handles order entry and delivery scheduling. This includes checking on product availability to ensure timely delivery and verifying customer credit limits. Unlike the previous example, customer orders are entered into the ERP only once. Because all users access a common database, the status of an order can be determined at any point. In fact, the customer will be able to check the order directly via an internet connection. Such integration reduces manual activities, saves time, and decreases human error. For business planning naman, it consists of forecasting demand, planning product production, and detailing routing information that describes the sequence and stages of the actual production process. For capacity planning and production planning, it can be very complex. Therefore, some ERPs provide simulation tools to help managers decide how to avoid shortages in materials, labor, or plant facilities. So once the master production schedule is complete, the data are entered into the material requirements planning module, which provide three key pieces of information: an exception report, the material requirements listing, and the inventory requisition. The exception report identifies potential situations that will result in rescheduling production, such as late delivery of materials. For the material requirement listings, it shows the details of vendor shipments and expected receipts of products and components needed for the order. And lastly is the inventory requisition. It is used to trigger material purchase orders to vendors for items not in stock. Shop floor control naman, it involves the detailed production scheduling, dispatching, and job costing activities associated with the actual production process. Finally, the logistic application is responsible for ensuring timely delivery to the customer. This consists of inventory and warehouse management as well as shipping. Most ERPs also include their procurement activities within the logistic functions. Next slide, please. Next is we have online analytical processing under the business analysis application. An ERP is more than simply an elaborate transaction processing system. It is a decision support tool that supplies management with real-time information and permits timely decisions that are needed to improve performance and achieve competitive advantage. Online analytical processing includes decision support, modeling, information retrieval, ad hoc reporting, analysis, and what-if analysis. Some ERP supports these functions with their own industry-specific modules that can be added to the core system. Other ERP vendors have designed their systems to accept and communicate with specialized bolt-on packages that third-party vendors produce. Sometimes, the user's organization's decision support requirements are so unique that they need to integrate in-house legacy system into the ERP. However, business analysis applications are obtained or derived. They are central to their successful function as a data warehouse. A data warehouse is a database constructed for quick searching, retrieval, ad hoc queries, and ease of use. The data are normally extracted periodically from a personal database or from a public information service. An ERP system could exist without having a data warehouse. Similarly, the organizations that have not implemented an ERP may deploy data warehouses. The trend, however, is that organizations that are serious about competitive advantage deploy both. The recommended data architecture for an ERP implementation includes separate operational and data warehouse databases. So we will examine issues related to the creation and operation of a data warehouse later. That's all for my part. Let me call on Mr. Fruelda to discuss the ERP system configuration.
Thank you so much for your discussion, Miss Aileen. A pleasant day to everyone. I am Ed Brian S. Fruelda, and today we are embarking on a journey of customization as we delve into ERP system configurations. An ERP system is like a canvas. It holds the potential to depict your organization's processes and strategies in a cohesive manner. By configuring the system, you mold it to your unique requirements, ensuring that it supports your business goals flawlessly. Throughout this session, we will explore how to tailor modules, workflows, and user interfaces to create an ERP system that is as unique as your organization. It consists of the following subtopics: server configurations, OLTP versus OLAP servers, database configuration, and bolt-on software. So get ready to unleash the art of tailoring ERP through configurations. Next slide, please. Server configurations. Most ERP systems are based on the client-server model. This is a form of network topology in which the user's computer or terminal, the client, accesses the ERP programs and data via a host computer called the server. The servers may be centralized, but the clients are usually located at multiple locations throughout the enterprise. Next slide, please. Onto the server configurations, there are two basic architectures. First, the two-tier model, and the second, the three-tier model. So let's dive deeper into these models. Next slide, please. So what is two-tier model? Next slide. The server handles both application and database duties. Client computers are responsible for presenting data to the user and passing user input back to the server. Some ERP vendors use this approach for local area network, commonly known as LAN, applications for which the demand in the server is restricted to a relatively small population of users. Also, the two-tier model of server configurations in an ERP system refers to the way that systems architecture is organized to manage and process data. In this model, there are two primary tiers of layers. First, the client tier and the server tier. Here's why this model is used and its benefits. Next slide, please. The first benefit is performance and scalability. In the total model, the client application, usually a desktop application, directly communicates with a database server. This reduces the complexity of the system and can lead to a better performance since there are few layers involved in data processing. Additionally, the server resources can be dedicated solely to database management, which can improve scalability and handle larger amounts of data and users. Next, we have reduced network traffic. With a two-tier model, most of the data processing and business logic are handled on the client side or the database server side. This means that only necessary data is transferred between client and server, reducing the amount of network traffic compared to more complex architectures. Next slide, please. On third benefit, we have faster response times. Because the client application interacts directly with the database server, response times can be faster compared to multi-tier models where data must pass through multiple layers before reaching the client. Fourth, we have simplified maintenance. Since there are only two main tiers in this model, the overall system is simpler to maintain and troubleshoot. Changes and updates can be implemented more easily without affecting the entire architecture. Next slide, please. Next slide. So we have here lower cost. So the two-tier model often requires less hardware and software infrastructure since it eliminates the need for intermediary application servers. This can lead to cost savings in terms of hardware, licensing, and maintenance. Next slide, please. The two-tier model of ERP system configurations offers simplicity, performance benefits, and reduced network traffic. However, it also presents limitations and challenges. First one, we have security concerns. The client-to-database communication ay maaaring ma-expose in a sensitive data. Kaya't mahalaga na magkaroon ng matatag na security measures upang mapanatili ang kaligtasan ng information. Next, we have the limited flexibility. If we say limited flexibility, it is a complex. So the business processes and a high number of users may not be well suited for this architecture, as it lacks the first scalability and distribution capabilities needed. Third, we have maintenance and upgrades. Ang mga upgrade ng client application ay maaaring maka-apekto sa lahat ng mga gumagamit. At mahalaga ang pagpatuloy ng pagkakaroon ng magandang performance ng application, which is sa client side previously mentioned, and the benefits of the two-tier model limitations. And of course, we have the client dependency. If we say client dependence, the performance and functionality of the client application significantly impacts the user experience, making its optimization crucial. In summary, the two-tier model of ERP system configurations is chosen for its simplicity, performance benefits, and reduced network traffic. However, it's important to carefully consider the specific needs of the ERP system and the organization's requirements before adopting this architecture. Next slide, please. As you can see, here is the illustration of a two-tier client-server model. Next slide, please. Now let's proceed with the three-tier model. The database and application functions are separated in three-tier model. This architecture is typical of large ERP systems that use wide area networks, or WANs. Kung kanina sa two-tier model, ang approach niya ay for local area network or LAN. Here in three-tier model is for wide area networks. Satisfying client requests requires two or more network connections. Initially, the client establishes communication with the application server. The application server then initiates a second connection to the database server. The three-tier model approach in ERP server configurations is an architectural framework that divides an enterprise resource planning system into three distinct layers of tiers. Each tier serves a specific purpose and interacts with the others to ensure efficient data processing, business logic management, and user interaction. So here's an explanation about the three tiers of this approach. Next slide, please. And so first we have the presentation tier, or commonly known as the client tier. This is the top layer that directly interacts with the end users. It consists of the user interface components such as web browsers, desktop applications, or mobile apps. The primary function of this tier is to present the information to users in a user-friendly and intuitive manner. Users interact with the system through this tier, inputting data, making requests, and receiving responses. The presentation tier also handles user authentication and authorization. So let's dive deeper into this tier. So sa tier na ito, nakikipag-ugnayan ang mga gumagamit ng ERP system sa pamamagitan ng web browser or mobile app. Ang mga customer ay naghahanap ng mga products na idinadagdag ang mga ito sa kanilang mga cart at naglalagay sa kanilang mga order. Nakikita nila yung list ng products sa kanilang mga cart at ang kanilang mga kasaysayan or the history of their orders sa pamamagitan ng user interface. So the presentation tier ay expose the experience ng mga gumagamit at mga nagpapakita ng mga products in a much designated designs, and also give way sa mga customer na nakipag-coordinate sa in this type of system. Next slide, please. Next, we have the application tier, or commonly known as middle tier. So the middle tier serves as an intermediary between the presentation tier and the data tier. It contains the business logic, processing algorithms, and application-specific rules. Here, user requests and input are processed, and necessary actions are taken. The middle tier interacts with the database tier to retrieve or update data as required. This separation of business logic from the presentation layer makes the system more modular and easier to maintain. So, ang middle tier ay naglalaman ng business logic na nagpapalakad sa mga operasyon ng e-commerce. Kapag naglalagay ng order ang isang customer, ang tier na ito ay nagpo-process ng kanilang mga orders. And of course, the prices, application of discounts, availability of the products. So in coordination with the module of the pagpamahala ng inventory management of the login credentials, like katulad na sa pag-access ng stocks. So the authentication na ginagamit natin dito is sinusuri natin at ini-authorize natin yung mga possible and potential actions natin for this. So if tayo or mga potential customers natin is gusto natin ibalik yung isang item, so sa pamamagitan ng application tier, so kasama yung pagkakaroon ng intensive assessment laban sa patakaran ng pagbabalik at pagpapasimula ng refund between the organization or the entity and the customer. Next slide, please. Next, we have the data tier or the server tier or database tier. So the data tier is responsible for managing and storing data. It includes the database management system where the ERP system's data is stored, organized, and retrieved. This tier handles data integrity, security, and performance optimization. The application tier interacts with the data tier to access or modify data based on the business logic. Centralizing data storage in the data tier ensures data consistency and reduces data redundancy. So next slide, please. Now, have you ever wondered what are the benefits of three-tier model or what ano yung advantages niya compared to a two-tier model? So, under the three-tier model benefits of the ERP server configuration, first we have the scalability. So each tier can be scaled independently, allowing for efficient allocation of resources. For instance, if there's an increase in user activity, you can scale the middle tier while keeping the data tier intact. Next, we have the modularity and maintainability. Separating the presentation, application, and data logic into distinct tiers makes it easier to maintain, update, and troubleshoot each component without affecting the others. Next slide, please. Third benefit, we have security. Since business logic is centralized in the middle tier and data is stored separately in the data tier, security measures can be more effectively applied and managed. Next, we have flexibility. Changes to the user interface or business logic can be implemented without impacting the underlying data structure or storage mechanisms. And lastly, we have the improved performance. So the middle tier can implement caching mechanisms to optimize data retrieval and processing, leading to improved system performance. However, it's worth noting that the three-tier model can introduce additional complexity and might require more infrastructure and specialized knowledge to set up and manage effectively. Nonetheless, the benefits it offers in terms of scalability, modularity, and security often make a preferred choice for many modern ERP systems. Next slide, please. Now let's jump into the illustration of a two-tier model limitations. As you can see, it is divided by three tiers. First tier, user representation layer. The second tier, the application layer. And the third tier, the database layer. Next slide, please. Now let's proceed with our second subtopic. We have the OLTP versus OLAP servers. When implementing an ERP system that will include a data warehouse, a clear distinction needs to be made between the competing types of data processing, OLTP and OLAP. OLTP events consist of large numbers of relatively simple transactions, such as updating accounting records that are stored in several related tables. For example, an order edit entry system retrieves all of the data relating to a specific customer to process a sales transaction. Relevant data are selected from the customer table, invoice table, and a detailed line item table. Each table contains an embedded key, which is used to relate rows between different tables. The transaction processing activity involves updating the customer's current balance and inserting new records into the invoice and line item tables. The relationships between records in such OLTP transactions are generally simple, and only a few records are actually retrieved or updated in a single transaction. So therefore, OLTP, the online transaction processing, and OLAP, the online analytical processing, are two different types of database systems designed to handle distinct tasks and workloads. So let's explore the differences between them. Next slide, please. First, we have an online transaction processing. So what is the purpose? OLTP systems are optimized for handling and managing day-to-day transactional operations of a business. These transactions can include activities like order processing, inventory management, customer interactions, and financial transactions. Workload. OLTP systems handle a high volume of short, frequent, and simple transactions. The emphasis is on fast response times and high concurrency to support many users simultaneously. Next slide, please. Next, we have the database structure. OLTP databases are typically normalized, meaning data is organized to reduce redundancy and ensure data consistency. This makes them suitable for data integrity and accuracy in transactional operations. Next, we have the queries. Queries in OLTP systems are usually simple and involve CRUD operations. CRUD means create, read, update, and delete on individual records. The focus is on retrieving and modifying specific pieces of data. And lastly, we have the data storage. OLTP databases store only a limited amount of historical data to support current transactions. The data is frequently updated and the focus is on the most recent data. Next slide, please. Now let's proceed with the OLAP servers, or the online analytical processing. So what is the purpose of OLAP? OLAP systems are designed for complex data analysis and reporting tasks. They are used to gain insights from large volumes of historical data and support decision-making processes. Next, workload. OLAP systems deal with complex queries that involve aggregations, calculations, and comparisons across large datasets. The emphasis is on providing analytical capabilities rather than quick transaction processing. Next slide. Now we have the database structure. OLAP databases often use a denormalized or star snowflake schema structure, optimizing them for query performance. This might involve storing redundant data to speed up complex joins and aggregations. Next, we have the queries. In OLAP systems, so it involves complex operations like grouping, sorting, filtering, and aggregating data. The focus is on providing a consolidated view of the data for analysis. And lastly, we have the data storage. OLAP database store a significant amount of historical data to support trend analysis and historical comparisons. Data updates are infrequent and the focus is on historical trends. Next slide, please. OLAP can be characterized as online transactions. So first we have access very large amounts of data, for example, several years of sales data. Analyze the relationships among many types of business elements such as sales, products, geographic regions, and marketing channels. Third, involve aggregated data such as sales volumes, budgeted dollars, and dollars spent. Fourth, we have compare aggregated data over hierarchical time periods, monthly, quarterly, and yearly. Next slide, please. Present data in different perspectives, such as sales by region, by distribution channel, or by product. Involve complex calculations among data elements, such as expected profit as a function of sales revenue for each type of sales channel in a particular region. And lastly, respond quickly to user requests so they can pursue an analytical thought process without being stymied by system delays. So an example of an OLAP transactions is the aggregation of sales data by region, product type, and sales channel. The OLAP query may need to access vast amounts of sales data over a multi-year period to find sales for each product type within each region. The user can further refine the query to identify sales volume by product for each sales channel within a given region. Finally, the user may decide to perform year-to-year or quarter-to-quarter comparisons for each sales channel. An OLAP application must be able to support this analysis online with rapid response. So in summary, OLTP systems are designed for fast and efficient transaction processing and are optimized for handling numerous simple transactions concurrently. Meanwhile, the OLAP systems, on the other hand, focuses on complex analytical operations, enabling businesses to gain insights from large volumes of historical data. The choice between OLTP and OLAP systems depends on the specific needs of the business and the types of tasks they need to perform with their data. Next slide, please. Now let's jump into our third subtopic for this discussion. We have database configuration. ERP systems are composed of thousands of database tables. Each table is associated with business processes that are coded into the ERP. The ERP implementation team, which includes key users and information technology, the IT professionals, selects specific database tables and processes by setting switches in the system. Determining how all the switches need to be set for a given configuration requires a deep understanding of the existing processes used in operating the business. Often, however, choosing table settings involves decisions to re-engineer the company's processes so that they comply with the best business practices in use. In other words, the company typically changes its processes to accommodate the ERP rather than modifying the ERP to accommodate the company. Next slide, please. So let's define the database configuration. So it refers to the processes of setting various parameters, options, and settings for a database management system to optimize its performance, security, and functionality. Proper database configuration is essential to ensure that the database meets the specific requirements and workload of the application it supports. Next slide, please. So here are some of the key aspects of database configuration. First, we have the storage configuration. It defines data file locations and sizes, configure log file settings for transaction management, set up appropriate buffer pool sizes for data caching. Memory configuration. Allocate memory for buffer pools, query caches, and other caches to improve query performance. Balance memory allocation between different components of the database system. Next slide, please. Concurrency configuration. Configure the number of allowed concurrent connections. Set parameters for locking and isolation levels to manage data consistency and concurrency. Next, we have performance tuning. Adjust parameters related to query optimization, indexing, and execution plans. Monitor and adjust configuration settings based on query performance analysis. Next slide, please. We have security configuration. It configures authentication methods for user access. Set up user roles, permissions, and access controls to ensure data security. Next and last, backup and recovery configuration. Configure backup schedules and retention policies. Define recovery options and strategies in case of data loss or system failures. So it is important to note that database configuration is not a one-time task, as workloads, date volumes, and application requirements change over time. Database administrators need to regularly review and adjust the configuration settings to maintain optimal performance and reliability. The specific configuration options and settings will depend on the type of database management system being used. For example, the MySQL, the PostgreSQL, the SQL Server, and the Oracle. And the unique needs of the application, it is recommended to refer to the documentation of the chosen DBMS for detailed guidance on configuring the database to suit your requirements. Next slide, please. So now we are finally here at our last stop, our subtopic, bolt-on software. Many organizations have found that ERP software alone cannot drive all the processes of the company. These firms use a variety of bolt-on software that third-party vendors provide. The decision to use bolt-on software requires careful consideration. Most of the leading ERP vendors have entered into partnership arrangements with third-party vendors that provide specialized functionality. The least risky approach is to choose a bolt-on that is endorsed by the ERP vendor. Next slide, please. Let's define the bolt-on software. So it refers to additional software modules or applications that are integrated with an existing software system to provide specific features, functionalities, or capabilities that the core system might lack. These bolt-on solutions are designed to enhance the overall functionality of the main software without requiring major changes to its core architecture. Also, the term bolt-on implies that these software components can be attached or added to the existing system, much like attaching an extra piece to a machine. This approach is often used to quickly address specific needs or requirements without undergoing a complete system overhaul. Next slide, please. So what are the key characteristics of bolt-on software? So first, we have the specialized functionality. Bolt-on software is usually developed to address a specific need or requirement that is not adequately met by the core system. Next, integration. Bolt-on solutions need to be integrated with the existing software. This integration can involve data exchange, APIs, connectors, or other means of communication. Next, we have modularity. Bolt-on modules are designed to be modular and independent from the core system. They can be added or removed without affecting the overall functioning of the core system. Next, we have the customization. Bolt-on software can be customized to match the unique requirements of the organization using it. This allows businesses to tailor the additional functionality to their specific processes. Next, we have the rapid implementation. One of the advantages of using both-on solutions is that they can often be implemented more quickly compared to building an entire system from scratch. Scalability. Both-on software can help organizations scale their operations by adding specific features as needed without needing to replace their entire software infrastructure. Next, we have vendor diversity. Organizations can choose different vendors for their both-on solutions, allowing them to select the best of breed options for their specific needs. And lastly, we have potential downsides. However, there can be challenges in terms of maintaining integration, data consistency, and managing different software components from various vendors. So to give you a specific example about this, about the both-on software, it also might includes adding a third-party analytics tool to a customer relation management system to provide advanced reporting and insights, integrating an e-commerce platform with an existing enterprise resource planning system to manage online sales and inventory, adding a project management tool to a communication platform to facilitate task tracking and collaboration. Organizations often opt for both on software because when they want to extend the capabilities of their current systems without undergoing a complete software replacement, or when they need specialized features that are not present in the core software offering. So that concludes my discussion about the bolt-on software. And also that concludes my discussion about the ERP system configuration. I hope you learned something and you have grasped something in my discussion. And now may I call on the next reporter, Miss Jenny Chico. The virtual stage is now yours. Thank you so much, everyone, and have a good day ahead.
Thanks for that, Mr. Fruelda. Let me greet everyone a pleasant day to all of you. And to continue with the discussion, I, Johnny Marie S. Chico, together with you, we're now moving forward to knowing more about the data warehousing. Let's get to know first what is a data warehouse. On to the next slide, please. So a data warehouse is a relational or multidimensional database that may consume hundreds of gigabytes or even terabytes of data storage. Meaning to say, data warehouse, dito tayo nag-store ng data, so it is more of a storage. So itong topic natin na data warehousing, this is one of the fastest growing IT issues in the business these days. Yung function kasi nitong data warehousing, naka-incorporate siya sa ating ERP system. So pag yung data warehouse natin ay for one function or one department only, we call it the data mart. So ang difference nila ay yung data warehouse, it consumes lots of storage. While yung data mart naman, it only has tens of gigabytes of data. On to the next slide, please. Let's now discuss the process of data warehousing. So in this process, we extract, convert, and standardize our data from our ERP and legacy system bago natin siya ilagay sa central archive, which is yung data warehouse. So pag nalagay na natin siya sa central archive, pag accessible na siya, that is the time na pwede na natin ito magamit for the data mining. But what is data mining? So data mining is the process of selecting, exploring, and modeling large amounts of data to uncover the relationships and global patterns that exist in large databases but are hidden among vast number of facts. So it involves sophisticated techniques that use database queries and artificial intelligence to model real-world phenomena from data collected from the data warehouse. So mostly, this organization, they implement the data warehouse as part of their strategic IT initiative that involves an ERP system. So to implement a successful data warehouse, onto the next slide, please. So they should install or create a process for gathering the data and then organize it to be able to be developed into a meaningful information that we can use into delivering this information to evaluation. So with that being said, we have essential stages for our data warehousing process. We have 5. First is modeling the data for the data warehouse, extracting data from operational databases, cleansing extracted data, transforming data into the warehouse model, and the last stage is loading the data into the data warehouse database. Let's get to know them one by one. Onto the next slide. Let's start with the first stage, which is modeling the data for the data warehouse. So in the previous chapter, we already know the importance of data normalization onto why it is necessary to do so. So the data warehouse consists of denormalized data because of its vast size warehouse database. But what does data normalization do? So normalizing the data in an operational database is necessary to reflect accurately the dynamic interaction among entities. So normalizing the data eliminates the update, insertion, and deletion anomalies. So in this data warehouse model, relational theory does not occur or happen pag stable yung dalawang attributes or variants. Like for example, if yung sales order and yung product ay stable, they do not need to have a link between them because that is a data warehouse. The relationship among these attributes does not change. So hindi dapat siya maiiba. So next slide, onto the second stage, we have, after we model the data warehouse, we needed to have the data extracted from the operational database. So data extraction is the process of collecting data from operational database, flat files, archives, and external data sources. So pag nag-extract tayo ng data from operational database, dapat walang ibang gumagamit nun at that moment. So it needs to be out of service to avoid data inconsistencies. So dahil need natin siya na mapabilis yung pag-extract, dapat wala tayong masyadong nagagalaw dito. Kaya nga dapat out of service siya. So there's this technique para mabawasan yung time ng pag-extract ng data, which is the change data capture. So this technique only gets the newly modified data. So next is extracting snapshots from versus the stabilized data. So transaction data are stored in operational database undergo economic events. Like for example, pag nakakakuha tayo ng sales transaction, kailangan muna niya ng credit approval bago natin i-process at i-ship yung order. Then pag na-receive na yung order ng customer, then we can get the payment pag nag-bayad na si customer. So this event, it changes our accounts inventory, accounts receivable, and our cash. So a key feature of the data warehouse is that the data contained in it are non-volatile or stable state. Potentially important relationship between entities may, however, be absent from the data that are captured in the stable state. So if there is canceled order pero na-ship out na, tsaka lang natin malalaman and reflect pag nasa warehouse na ulit yung item. So to be able to reflect it, we needed to get the data in slices of time when we receive it. So that is what we call the snapshot of the business activity that helps in depicting the losses of the company. So next slide, after we model, we are preparing invalid data prior to being stored in the data warehouse. Operational data are dirty. So data cleansing also involves transforming data into standard business terms with standard data values. So operational data are dirty, that is for many reasons. So there can be errors, blank fields, misspelled names, illogical data that are being entered in the data entry that makes the data being called dirty. So data cleansing means transforming this data into standardized values and business terms that we can be able to distinguish them from other data or variable in our data warehouse. So during this cleansing process, the attributes that came from multiple systems, we will transform them into a uniform one, standardized business terms, which can really be expensive at matrabaho siya, but that is our way to maintain the integrity of the data warehouse. And that covers my part. And to discuss with you the next essential stages of the data warehouse, I have here Mr. Jeuen Caraig to continue the discussion.
Thank you, Ms. Chico. So to continue the steps for the data warehousing process, the fourth process is transforming data into the warehouse model. So ang data warehouse daw ay composed of parehong detailed and summarized data. Bago i-load ang data sa warehouse, pwede natin i-summarize yung data to work more efficiently. For example, yung product sales. Pwede yan nakasummarize. Sabihin natin weekly product sales, monthly product sales, quarterly, annually, and so on. Kapag kasi nagsasummarize lang tayo kung kailan need yung data, impractical na, di ba? So having pre-summarized views help for better efficiency. And having itong mga summarized views sa data warehouse can make analysis faster and reduce processing time. Kasi nga nakasummarize na yung mga data according sa kung anong kailangan ng management. A data warehouse may also provide various summarized perspectives from the same detailed information. So using a detailed information, kaya nitong mag-provide ng maraming summarized na perspectives. For example, pwedeng makuha mula sa mga sales order data ang summary based on product, an example is ano-anong mga, for example, kung saang mga regions tayo mas nakakabenta. Yung mga summaries na ito helps analysts to explore underlying data by drilling down. More of this in the succeeding slides. Detailed data is crucial to understand trends, patterns, and unusual situations shown on summaries. So parang kanina yung sa regions, pwede nating malaman, ay dito sa region na to parang tumataas yung sales natin na, ay yung product na to parang mas nagiging mabenta nung fourth quarter or kapag bare months ba. Dahil summarized ang data, mas madali natin makikita ang mga trends and patterns, and especially kung may unusual ba na nangyayari. So the last step in the data warehousing process is loading the data into the data warehouse database. Maraming organizations ang preferred na kailangan separate ang data warehouse from the operational databases or yung sa transaction processing para maging successful ang data warehousing. So here are the following reasons kung bakit. First is internal efficiency. So magkaiba kasi ang pangangailangan ng transaction processing at ng data mining. It is impractical to store both operational or current and archive data in the same database dahil meron silang magkaibang demands. Specifically, transaction systems require a structure that ensures efficiency, while yung data mining systems naman needs data na organized na in a manner that permits broad examination and detection of underlying trends. Kumbaga sa data mining system kasi, parang trends ang tinitignan, yung bigger picture ng operations. Whereas sa transaction systems, naka-organize siya in a way na magiging efficient yung operations. Second is the integration of legacy systems. Yung legacy systems kasi outdated na. Noong 1970s pa siya na-develop. So the way this system stored data does not align well with modern data analysis tools. Kumbaga, di na siya compatible sa mga makabagong analysis tools. Kaya ang nangyayari is, kumbaga natatambak na lang yung mga data from other systems na ito kasi nga di na siya madaling ma-access dahil outdated na siya. So nakakatulong yung pagkakaroon ng separate data warehouse para mapag-combine itong mga luma sa bagong systems in a way na mapapadali ang pag-analyze and pag-understand sa mga trends across the entire organization. So the last reason kung bakit mahalaga magkaroon ng data warehouse ay consolidation of global data. So nakakatulong ang pagkakaroon ng isang centralized data warehouse para i-gather, i-organize at i-unify ang data from various sources. Applicable to especially for sa mga multinational companies na nag-ooperate sa iba't ibang bansa. For example, di ba yung mga iba't ibang bansa kasi may iba't ibang currency pa yan sila. And nagpa-fluctuate pa tong mga currency na to. So mahirap kung mag-outsource ka ng data ng sales for Philippines, sales sa China, sales sa US, individually mo pa i-acquire from different countries, then i-translate mo pa sa current exchange rate and so on. Dahil nga may centralized data warehouse, ando na lahat, di na kailangan mag-source pa from different segments or divisions per country kasi nga centralized na ang database. So to conclude, core concept itong pagkakaroon ng separate data warehouse from operational systems or yung mga transaction processing systems, kaya nag-i-invest ng malaki ang madaming organizations para lang magkaroon sila ng separate data warehouses alongside operational systems. Next naman ay titingnan natin yung mga decisions supported by the data warehouse. A flexible and user-friendly data warehouse allows easy access for many users. So one advantage ng data warehouse from traditional databases is that it enables multidimensional analysis and information visualization. Routine reports and standard queries can be automatically generated, reducing access, activity, and improving efficiency. So na-automate na ang mga routine reports and mga standard na queries, thereby improving efficiency. Sinusupport din ng pagkakaroon ng data warehouse ang pag-drill down analysis. So drill down analysis is a valuable technique in data mining. It is an OLAP feature of data mining tools available to the user. It starts with summarized data views and allows users to explore anomalies and trends. When anomalies or interesting trends are observed, the user drills down to the lower level views and ultimately into the underlying data. Such analysis cannot be anticipated like a standard report. Ayan, so for example, dun sa mga summarized data, nakakita tayo ng anomalya. Nakita natin na bumaba yung sales noong sabihin natin 2022. Ay, parang medyo bumaba yung sales natin compared sa 2021. So, nag-drill down tayo. Kumbaga, chinap-chop natin yung quarterly ng sales. Nakita natin, ay, yung third quarter pala, bumaba yung sales. Then, nag-drill down pa tayo sa third quarter kung bakit. Hanggang sa nakita natin yung pinakapunot dulo. For example, yung third quarter pala, nagka-shortage ng ganitong material, kaya kaunti lang ang nabenta and so on. Sa isang standard report kasi, hindi ka makaka-drill down. So, yun yung isang advantage ng data warehouse. Standard reports and queries produced from summary views can answer many what questions, while drill down capability answers why and how questions. So tulad nga ng sinabi ko kanina, yung mga standard reports, nakikita natin yung mga, for example, what is the total sales for this year, what country yung may pinakamababang sales. Then pag nag-drill down naman, makikita na natin yung why sa ganitong country mababa yung sales and how or paano nangyari yon. So here are some of the applications of data mining in different business fields. So sa banking and investments, pwede na-apply yung data mining sa pagdetect ng patterns of fraudulent credit use, identify loyal customers and predict those likely to change their credit card affiliation, examine historical market data to determine inventor stock trading rules, predict credit card spending of key customer groups, identify correlations between different financial indicators. Sa healthcare and medical insurance naman na business field, na-apply natin ang data mining sa pag-predict ng office visits from historical analysis of historical patient behavior, identify successful and economic medical therapies for different illnesses, identify which medical procedures tend to be claimed together, predict which customers will buy new policies, identify behavior patterns associated with high-risk customers, and identify indicators of fraudulent behavior. And lastly, sa marketing business field naman, we can apply data mining by identifying buying patterns based on historical customer data, identify relationships among customer demographic data, and predict response to various forms of marketing and promotion campaigns. So next topic naman ay supporting supply chain decisions from the data warehouse. So yung mga data warehouse ay nasusuportahan din ng mga decisions natin regarding sa supply chain by sharing data externally with customers and suppliers to improve relationships and service quality. Utilizing technologies like the internet and the online analytical processing or OLAP applications enables organizations to share their data warehouse with patterns and treat them as part of the company. So ang pag-share externally sa mga suppliers and customers ng data warehouse can lead to a more efficient supply chain. So one example is yung supply chain data warehouse ng GM Motors. So na-access ito ng kanilang mga suppliers securely online. So magla-login muna sila doon, then they can check na yung mga quantities of supplies shipped, delivery schedules, and prices ng mga materials. Yung pagkakaroon ng ganito can help yung mga suppliers ng GM to optimize their product planning, ability to source materials, and shipping fulfillment processes. Kumbaga, nai-ready na ng mga suppliers yung possible na demand quantity or kung yung ilan yung possible na orderin ni GM para makapag-ready na sila ng stocks nila and so on. Another example is sa customer side naman. So MIM Health Plans Incorporated allows their customers to access warehouse data to promote better buying decisions. Meanwhile, benefits managers can use the reports and drill down into the warehouse so they can analyze claims, cost, overall expenses, prescription orders over a specific name, brands versus generic drug ratios, and other decision-making metrics. So isang benefit ng pag-share sa mga customers ng data warehouse ay napapadali ang pag-obtain ng data mula sa mga customers na nagagamit para sa decision-making reports ng isang organization. So that ends my report. May I now call on Ms. Baranda to continue our presentation and discuss the different risks associated with ERP implementation. Thank you.
Thank you, Mr. Caraig. I'm Guiliana Baranda, and I'll be the one reporting the risks associated with ERP implementation. While enterprise resource planning systems or ERP systems can bring significant benefits, they also come with risks. It's important to keep in mind that implementing an ERP system won't magically fix all of the organization's issues. There may be other factors at play that need to be addressed to see the desired improvements. Organizations must carefully consider this risk, and this part examines some of the risk issues that needs to be considered. Next slide, please. Big bang versus phased-in implementation. Implementing a new ERP system can be challenging as it requires a collective effort to align the entire organization with new business processes. In a big bang implementation, the entire new system is launched all at once, replacing the old system completely. So this method is risky and ambitious. Although this method has certain advantages, it has been associated with numerous system failures. Since the switch happens all at once, there's a relatively shorter period of overlap where both old and new systems coexist. So it allows full focus on the new system, but there are also risks of disruption and potential losses if unexpected issues arise. So new system implementations often cause disruptions to daily operations. Because of the disruptions associated with the Big Bang method, the phased-in approach has appeared as a popular alternative. Next slide. The phase-in implementation is the approach where anything new is rolled out in stages rather than all at once. This approach can give employees more time to adjust to changes. Cautious transitions allows for comprehensive problem solving and feedback gathering, leading to adjustments and improvements. Phase-in implementations are complex and require additional resources. The transition period can be longer, delaying the benefits of the new system. So in conclusion, whether Big Bang or phased-in, it still depends on the context, risk, organization capacity, and the stakeholder preferences. Next slide. Now we have here the opposition to changes in the business culture. For successful ERP implementation, all functional areas of the organization should continue to contribute to defining the new system's requirements and the firm's culture. The firm's willingness and ability to undertake a change of the magnitude of an ERP implementation is an important consideration. If the corporate culture does not embrace change, ERP implementation may not be successful. The technological culture must also be assessed. Companies without technological support for the new system or with employees who are not familiar with computer technology may struggle to get their workers to accept the new system. Next slide. So choosing the wrong ERP. ERP systems must align with the organization's culture and business processes to avoid failure. If the ERP cannot support important business processes, it is likely to fail. Goodness of fit. Management needs to make sure that the ERP they choose is right for the company. However, no single ERP system can solve all the problems of all the organizations. But an ERP system that fits well can accommodate future growth and changes in business processes more easily. Scalability issues in an ERP system refers to challenges that arise when the system struggles to handle increased demand, growth, or complexity. The inability of a system to rise or down can lead to a range of issues, including and increased costs. It is therefore critical to address scalability issues in a timely and effective manner to ensure optimal performance and growth of the organization. Picking the right ERP system is crucial for your organization's efficiency, competitiveness, adaptability, thorough research, and alignment with your needs ensure successful implementation and long-term success. Next slide. So choosing the wrong consultant. Selecting the wrong consultant for an ERP implementation can be risky. A knowledgeable and experienced consultant can improve the project's success, but a poor choice can lead to problems. So when selecting an ERP consultant, it's crucial to thoroughly evaluate their track record of success implementations, relevant industry experience, and deep understanding of the ERP system. So many people often complain that consulting firms make promises of providing experienced professionals, but they end up delivering incompetent claims instead. So by conducting in-depth interviews, you can ensure that you can choose a consultant who aligns with your organization's needs and goals. Next slide. High cost and cost overruns. The cost of ERP systems can vary significantly, ranging from hundreds of thousands to millions of dollars depending on the size of the implementation. The total cost of ownership or TCO covers hardware, software, consulting, personnel, installation, and maintenance for the first 2 years. So underestimated and unforeseen costs pose a risk. Next slide. So some of the more commonly experienced problems occur in the following areas, with training and system testing and integration. Training costs are often higher than expected because management only focuses on software teaching costs and overlooks the additional need for the new procedure training. While ERP testing and integration are done on a case-to-case basis, therefore the cost is extremely difficult to estimate in advance. Next slide. The database conversion. So switching to a new ERP system means moving data from the old system to the new one. If the old data is reliable, automation can handle transfer, but testing and reconciliation are still necessary to ensure accuracy. The last one is the develop performance measures. Because ERPs are extremely expensive to implement, many managers are often alarmed at the obvious lack of cost savings that they achieve in the term. The success of ERPs is examined based on whether their benefits overpower their costs. With that, to determine benefits, management should establish key performance measures that reflect their expectations. Now, I hope you learned something. I am now going to call Ms. Lacson and Ms. Dalangin to explain the implications for internal control and auditing.
For the last risk associated with ERP implementations, we have disruptions to operation. ERP systems can wreak havoc or inflict great damage in the companies that instance them. 25% of the companies surveyed admitted that they experienced a drop in performance in the period immediately following implementation. The re-engineering of business processes that often accompanies ERP implementation is the most commonly attributed cause of performance problems. Operationally speaking, when businesses begin under ERP system, everything looks and works differently from the way it did with the legacy system. And an adjustment period is needed for everyone to reach a comfortable point on learning curve. So depending on the culture of the organization and attitudes towards change within the firms, adjustments may take longer in some firms than in others. And the most notorious disruption case in press was Hershey's Foods Corporation, which had trouble processing orders through its new ERP system and was unable to ship products. As a result of these disruptions, Hershey's 1999 third quarter sales dropped by 12.4% compared to the previous year's sales, and earnings were down by 18.6%. So Hershey's problems has been attributed to two strategic errors related to system implementation. First, because of schedule overruns, they decided to switch to the new system during their busy season, in which it is easier to deal with during slack business periods. Secondly, many experts believe that Hershey's attempted to do too much in a single implementation. In addition to the R/3 system, they implemented a customer relations managed system and logistics software from two different vendors, which had to interfere with the RC. Now that we know the different risks, let's move on to the next slide. We have the implications for internal control and auditing. As with any systems, the internal control and audit of ERP systems are issued. Key concerns are examined next within the SAS 78 or the COSO framework. First, we have the transaction authorization. A key benefit of an ERP system is its tightly integrated architecture of modules. This structure, however, also possesses potential problems for transaction authorization. For example, the bill of materials drive many manufacturer systems. If the procedures for the creation of the bill of materials are not configured correctly, every component that uses the bill of materials could be affected. Controls need to be built into the system to validate transactions before other modules accept and act upon them. Because of the ERP's real-time orientation, they are more dependent on program controls than on human intervention, as was the case with legacy systems. The challenge for auditors in verifying transaction authorization is to gain a detailed knowledge of the ERP system configuration, as well as a thorough understanding of the business processes and flow of information between system components. Next slide, please. Now we have the segregation of duties. Operational decisions in ERP-based organizations are pushed down to a point as close as possible to the source of event. Manual processes that normally require segregation of duties are therefore often limited in the ERP environment. For example, shop supervisors may order inventories from suppliers, and receiving box personnel may post inventory system or may post inventory receipts to the inventory record in real time. Furthermore, ERP forces together many different business functions such as order billing, accounts payable under a single integrated system. Organizations using ERP systems must establish new security, audit, and control tools to ensure duties are properly segregated. An important aspect of such control is the assignment of roles, which will be discussed on a later section. Next slide, please. Third one is the supervision. An often cited pitfall of an ERP implementation is the management does not fully understand its impact on business. Too often, after the ERP is up and running, only the implementation team understands how it works. Because their traditional responsibilities will be changed, supervisors need to acquire an extensive technical and operational understanding of the new system. Typically, when a organization implements an ERP, many decision-making responsibilities are pushed down to the shop floor level. The employee-empowered philosophy of ERP should not eliminate supervision as an external control. Instead, it should provide substantial efficiency benefits. Supervisors should have more time to manage the shop floor and through improved monitoring capability, increase their span of control. Next slide, please. For the accounting records, ERP systems have the ability to streamline the entire financial reporting process. In fact, many organizations can and do close their books daily. OLTP data can be manipulated quickly to produce ledger entries, accounts receivable and payable summaries, and financial consideration for both internal and external users. The additional batch controls and audit trails are no longer needed for many cases. This risk is mitigated by improved data entry accuracy through the use of default values, cross-checking, and specified user views of data. In spite of ERP technologies, some risks to accounting records accuracy may still exist. Because of the close interface with customer and suppliers, some organizations run the risk that corrupted or inaccurate data may be passed from these external sources and corrupt the ERP accounting database. And to continue the rest of the implications of internal control, here's Ms. Dalangin.
Thank you, Ms. Lacson. Good day, everyone. I, Dalangin Kate Michelle M, will now proceed to the remaining implications for internal control and auditing. So let us now proceed to independent verification. Independent verification. Because ERP systems employ OLTP, traditional independent verification controls such as reconciling batch control numbers serve little purpose. Similarly, process reengineering to improve efficiency also changes the nature of independent verification. For example, the traditional three-way match of the purchase order, receiving report, and invoice, and the subsequent writing of a check may be automated in an ERP environment. Next slide, please. So the focus of independent verification thus needs to be redirected from the individual transaction level to one that views overall performance. ERP systems comes with canned controls and can be configured to produce performance reports that should be used as assessment tools. On the other hand, internal auditors also play an important role in this environment and need to acquire a thorough technical background and comprehensive understanding of the ERP system. Ongoing independent verification efforts can be conducted only by a team well-versed in ERP technology. Next slide, please. So we have the access controls for this slide. Access security is one of the most critical control issues in an ERP environment. The goal of ERP access control is to maintain data confidentiality, integrity, and availability. Security weakness can result in transaction errors, irregularities, data corruption, and financial statement misinterpretations. Next slide, please. Also, uncontrolled access exposes organizations to cyber criminals who steal and subsequently sell critical data to competitors. Security administrators therefore need to control access to the tasks and operations that process or otherwise manipulate sensitive corporate data. Next slide, please. So we have traditional access control models. Traditionally, the owner of system resources or the data, functions, and processes grants access privileges individually to users based on the individual's trust level and job description. Access control is typically achieved via an access control list or access token within the user's application. The access control list specifies the user ID, the resources available to the user, and the level of permission granted to such as read-only, edit, or create. Although this model allows for the assignments of a specific privileges to individuals, it is quite inflexible. The sheer volume and variety of access privilege needs in modern ERP environment present a significant administrative burden. So the best example for this for us like students is Google Drive. Even before the pandemic came, we were already using this platform to share access to files and perform collaboration. We also have option of granting access to our users. We can make it read only or allow them to edit or create. And this surely needs time for us to designate access for our users, which is quite inflexible. Next slide, please. So any access granting model must efficiently keep up with new hires, changes to existing privileges brought about by promotions and individuals transferring from one department to another, and personal terminations too. To meet these demands, modern ERP system employ role-based access control or the RBAC which is to be discussed on the next one. So we have here the role-based access control, or the RBAC. It is a role that is a formal technique for grouping together users according to the system resources they need to perform their assigned tasks. So next slide, please. For example, a system administrator could create a sales role for sales department personnel that permits access only to the ERP sales module and certain documents such as customer orders, sale orders, and customer records. When an employee joins the sales department, whether a new hire or a transfer from another department, he or she will be assigned to the sales role and through it can access its pre-specified resources. Next slide, please. Figure 11-8 illustrates the differences between RBAC and the traditional access control list approach. Notice from the figure how this technique assigns access permissions to the role and an individual plays in the organization rather than directly to the individual. Therefore, more than one individual can be assigned to a role and a predefined set of access permissions. Also, an individual may be assigned more than one role, but can log into the system only under one role at a time. Thus, RBAC conveniently handles many-to-many relationships between users and permissions and facilitates dealing efficiently with vast numbers of employees. Next slide, please. So ERPs come with predefined roles and pre-assigned permissions. Administrators and line managers may also create new roles, modify existing roles, and delete roles that are no longer needed. Creating a role involves defining the following role attributes. So we have the first one, a stated set of business responsibilities to be performed within the role. The second one is the technical competencies needed to perform the role. And the last one is the specific transactions or permissions required to carry out the stated responsibilities. Next slide, please. So here we have the figure 11-9, which presents a SAP role definition for an accounts payable role in a hypothetical organization. The individual assigned this role is governed in his or her access to specific SAP program modules. In this case, we have the AP, and to specific activities within the module by the transaction role code list in the SAP security consideration section of the role definition. So next slide, please. Moving on to the next one, we have the internal control issues related to ERP roles. So although RBAC is an excellent mechanism for efficiently managing access control, the process of creating, modifying, and deleting roles is an internal control issue of concern for management and auditors alike. So the following points highlight the key concerns. So number one, we have the creation of unnecessary roles. Number two, we have the role of least access should apply to permission assignments. And lastly, we have monitor role creation and permission granting activities. Next slide, please. So as what I've said earlier, the creation of unnecessary roles. So the fundamental objective of RBAC is to provide access in accordance with an organization's needs, which derive from defined tasks rather than an individual's wants. We have to take note of this. Managers in ERP environments, however, have significant discretion in creating new roles for individuals. This may be done for employees who need access to resources for special and or one-time projects. Such access granting authority needs to be tempered with judgment to prevent the number of roles from multiplying to the point of becoming dysfunctional and thus creating a control risk. Indeed, an oft-cited problem in ERP environment is that roles tend to proliferate to a point at which their number actually exceed the number of employees in the organization. Policies need to be in place to prevent the creation of unnecessary new roles and to ensure that temporary role assignments are deleted when the reason for them terminates. Next slide, please. We now have the rule of least access. I already mentioned this earlier, which is all about the access privileges or permissions that should be granted on a need-to-know basis only. Please take note of this. Nevertheless, ERP users tend to accumulate and unneeded permissions over time. So this is often due to two problems, and we have this on the next slide, please. So the first one, managers fail to exercise adequate care in assigning permissions as part of their role granting authority. Because managers are not always experts in internal controls, they may not recognize when excessive permissions are awarded to an individual. So for the last one, we have the managers tend to be better at issuing privileges than removing them. So nagpo-focus sila sa pagbibigay pero nakakalimutan din nila na magbawas sa mga ginrant nilang access sa mga employees na naka-assign. As a result, an individual may retain unneeded access privileges from a previous job assignment that creates a segregation of duties violation when combined with a newly assigned role. Policy should be in place to require managers to apply due diligence in assigning permissions to roles to avoid the granting of excessive access. They should assign privileges based on the task at hand and be aware of the individual's existing permissions that may pose a control violation. So next slide, please. As what we have discussed earlier, we have to monitor role creation and permission granting activities. Effective RBAC management demands procedures that monitor role creation and permission granting to ensure compliance with internal control objectives. Verifying role compliance across all applications and users in an ERP environment, however, poses a highly complex and technical problem that does not lend itself to manual techniques. So role-based governance systems are available for this purpose. These systems allows managers to first view the current and historical inventory of roles, permissions granted, and the individuals assigned to roles. Next, we have to identify unnecessary and inappropriate access entitlements and segregation of duties violations. And lastly, we have verified that changes to roles and entitlements have been successfully implemented. These systems can continually monitor for risk and issue alerts when violations are detected so that remedial action can be taken. In addition, role-based governance can maintain an audit trail to provide a record of violations and evidence of compliance. Next slide, please. So for implications for internal control and auditing, we have the last one, the contingency planning. The implementation of an ERP creates an environment with a single point of failure, which places the organization at risk from equipment failure, sabotage, or even natural disaster. To control this risk, an organization needs an effective contingency plan that can be invoked quickly in the event of a disaster. Two general approaches are outlined next, but a more extensive discussion is presented in Chapter 15 within the broader context of IT governance. So, centralized organizations with highly integrated business units may need a single global ERP system that is accessed via the internet or private lines from around the world to consolidate data from subsidiary systems. A server failure under this model could leave the entire organization unable to process transactions. To control against this, two link servers may be connected in redundant backup mode. All processing is done on one server. So next slide, please. So we have to take note that if it fails, processing is automatically transferred to the other server. Organizations that want more security and resilience may arrange servers in a cluster of 3 or more that dynamically share the workload. Processing can be redistributed if one or more of the servers in the cluster fail. Companies whose organizational units are autonomous and do not share common customers, suppliers, or product lines often choose to install regional servers. This approach permits independent processing and spreads the risk associated with server failure. So that next slide, please. That is all for our report for Chapter 11, the Enterprise Resource Planning Systems. And together with Mr. Caraig, Mr. Fruelda, and Ms. Baranda, Ms. Chico, Ms. Lacson, Ms. Mullion, we hope you learned a lot from this video lecture. Thank you for listening and have a great day ahead.